Okay, in this video we go over example 5.7 and 5.9 from the book. These show you how to do binomial distribution problems using the BinomialDist formula in Excel. So problem 5.7, what they have is that we're looking at people purchasing something. And historically, the probability of a purchase is 40%, which comes from example 5.6. If you go up to where 5.6 is, they say the historical sales record indicate that 40% of all customers who enter will make a purchase. So we know that just from historical evidence. So out of the next 5 people who come in, so example 5.7 is out of the next 5 people come in, what is the probability that 3 will make purchases? Exactly 3. Probability of exactly 3. Well, let me show you a couple ways to solve this thing using Excel and the BinomialDist formula. So the fast way, the easiest way, is that we're going to use the BinomialDist, and it takes 4 arguments, 1, 2, 3, 4. The first argument is the number of successes. I want to know the probability of exactly 3, so my number of successes is 3 out of how many? The number of trials is 5. The probability of success historically for a purchase is 40%. The last argument is the trickiest one. If I'm solving for exactly, if it says equal to 3, you put 0 because you do not want the cumulative. We'll do example 5.9 and you'll see when we use 1. So the last argument is either 0 or 1. If it says equal here, if you're solving for exactly or equals, put 0, and there's the answer, which is the answer in the book. You could have solved it this way. Let me just show you another way to do it. So if you have 5 purchases, here's the purchase. If you have 5 people come in, you can either have 0 purchases, 1, 2, 3, 4, or 5. The probability of that purchase probability of this many successes out of this, I'm going to put some dollar signs around this because I'm going to copy it down. Probability of success, 1 purchase, and 0 is my last argument. Need to put some dollar signs around my probability. So that's the probability of 0 purchases. Copy this all the way down. Probability of 1 purchase, 2 purchases, 3 purchases, 4, or 5. And if you add those up, guess what it sums to? So you can think of it this way, and then this number is this number. You could certainly plot that if you wanted to. You don't have to, as some type of probably scatter plot or a line chart or something, but there's that's what that is. Okay, let's do example 5.9. Excuse me, 5.8. Is it 5.8 or 5.9? Yeah, 5.9. And what I want to know is find the probability that x is greater than or equal to 3. See that one right there? There's a couple of ways to do this one, greater than or equal to 3. We can do this by finding the probability that x is equal to 3 and the probability that x is equal to 4. And in this case, we're looking at the chance that people get sick after they take a drug. And the probability of that happening overall historically is about 10%. I give 4 people a trial. I bring 4 people in and give them the drug. And I want to know the probability that either 3 people or 4 people. So that's what this number is. So you could do it this way. And this is perfectly fine. Get 3 out of 4. Number of the probability of success, and then put 0 as your last argument. Again, I'm going to copy this down, so I'm going to put dollar signs around those. So there's 3, there's 4, whoops, that one should be 4. And you add those up, so that's the answer right there. That's exactly how they did this. Another way that you could do this, and this is the probability that x is greater than or equal to 3 is also equal to 1 minus the probability that x is less than or equal to 2. Because this is the probability of 0, 1, or 2. They have to total to 1. The probability that x is greater than or equal to 3 is 1 minus the probability that x is less than or equal to 2. And so, how can I solve for that? Using, and I'll show you. So I'm going to 1 minus, then I put binom.dist. Now I'm focusing on this part. You can see how that's less than or equal to 2. Up here we had equal to 3. Now we have a less than or equal to. When you have less than or equal to, your last argument should be 1. So the number of successes is 2 out of 4. The probability of success for one trial is this, and then the last argument, instead of putting 0, put 1. And this will give you the probability that of 2 or less. And so if I want to find the probability of 3 or more, I subtract this from 1. There you go. You get the same answer as this one. Okay, thanks.